Hi, everyone. Thank you. And thank you, everyone online, for joining. Just going to move this really quickly. So hello, everyone. My name is Karema Seliem, and I'm a LEED specialist at the U.S. Green Building Council, as Sarah mentioned, in Washington, D.C. And in my role, I serve as a sustainable sites, resilience, and social equity expert on the LEED technical development team. I want to thank you for joining us today, and I want to thank the Cool Roof Rating Council for their generous invitation to speak. And I'm here today to talk to you about how LEED addresses heat mitigation and the new discussions we are having regarding addressing extreme heat. Just out of curiosity, please raise your hand if you're familiar with LEED. Awesome, great, that's most of the room. Now please raise your hand if you're a LEED accredited professional. Oh, we got to raise that number, guys. Awesome. Oh, I got it. Sorry. So this first section is just a basic background information on the urban heat island effect for anyone who's not familiar, though I'm sure a good majority of you are. Urban heat islands are urbanized areas that experience higher temperatures than surrounding rural and less densely developed areas as a result of structures such as buildings, roads, and other infrastructure that reflects the sun's heat more than natural landscapes. And daytime temperatures in urban areas are about 1 to 7 degrees Fahrenheit higher than temperatures in surrounding rural areas, and nighttime temperatures are about 2 to 5 degrees Fahrenheit higher. Urban heat islands are also worse in extreme heat events such as heat waves, and thus the environment and residents living in heat islands are unfairly subject to the negative impacts. Higher temperatures in cities are caused by the lack of natural landscapes and cool surfaces, lack of green spaces, water bodies, trees that regulate temperatures through evapotranspiration, evaporating surface water, and providing shade, respectively. Urban infrastructure and the way cities are constructed and the materials they are constructed with have a huge impact on how urban microclimates are shaped. And in urban areas, dimensions and spacing of tightly packed urban spaces impacts wind flow pattern and how solar radiation is absorbed and emitted. Lastly, anthropogenic heat is the increase in temperatures caused by human activities like vehicles, air conditioning, heating, and buildings and industrial facilities in urban areas that generate and emit waste heat more than in rural areas. These higher temperatures combined with other climate phenomena such as humidity and dew point have numerous impacts on the urban environment and residents' heat experience. So some environmental impacts of urban heat islands are increased air pollution and degraded water quality. For air pollution, since temperatures are higher in urban heat islands, especially during heat waves, there are higher energy demands for air conditioning and other cooling strategies. And the increased use of electricity leads to more greenhouse gas emissions from fossil fuels, and this contributes to localized air pollution as well as exacerbating global climate change. Along with air pollution, urban heat islands also deteriorate water quality. One study found that urban streams are hotter on average than streams in forested areas, and that temperatures in urban streams rose over 7 degrees Fahrenheit during small storms due to heated runoff from urban materials. And I'll be switching back and forth from degrees Fahrenheit to degrees Celsius, depending on the study that we cited, so just a heads up. Urban heat island effect also has devastating consequences on infrastructure and human health. With the consistently higher temperatures in urban areas and the especially high temperatures during heat waves, building materials like tarmac, concrete, and steel are all affected negatively and deteriorate much faster due to temperature fluctuations. Along with that, power grid failures become more common as energy demand increases due to increased cooling requirements. According to a study done by the University of New South Wales, there will be a 12% increase in cooling demand in urban heat islands compared to the demand under reference rural climate conditions. And this increase in demand leads to power grid failures because the current grid is inadequate to handle the rise. And this is already impacting thousands of urban residents in the US as blackouts nearly doubled from 2015 to 2020. The rolling blackouts in the Northwest US last summer is also another example of the insufficient power grid in increasingly warming areas. Urban heat islands, higher daytime temperatures, reduced nighttime cooling, and air pollution has severe impacts on human health and comfort, especially for sensitive populations such as older adults, young children, and low-income populations, outdoor workers, and those with compromised health like chronic conditions such as asthma, diabetes, or physical and cognitive disabilities. Heat-related illnesses that these populations are susceptible to are general discomfort, respiratory difficulties, heat cramps, heat exhaustion, and non-fatal heat strokes. And according to the CDC, over 65,000 people visit emergency rooms for acute heat illness each summer. A Duke University study found that an average of 12,000 premature deaths occurred annually in the US during the last decade, and projected deaths rise to 110,000 annually under a business as usual warming scenario due to climate change. As climate change worsens, it contributes to and exacerbates urban heat islands in cities by raising overall temperatures, as well as increasing the frequency and intensity of extreme heat events, as shown in figure 3 on this slide. UHI warming will be equivalent to half the warming caused by climate change by 2050. And this in turn will increase islands and their impact on humans and the environment. Since urbanization is also projected to increase from the current 55% to 68% by 2050, more and more urban residents will be vulnerable to the impacts of heat islands, extreme heat, and climate change. Because of the urgency and severity of the matter, it is even more important to mitigate the damaging impacts of urban heat islands and do so with equity and community at the forefront of the conversation. So moving on to our next section, I'll discuss heat equity and historical causes for inequitably distributed vulnerable populations. So in addition to my role at USGBC, I'm also an adjunct professor at Drexel University in Philadelphia, where I teach a course titled Social Equity in Communities. The course explores the historical context and policy decisions and implementation practices that have led to the development of a built environment that separates populations and continues to enable structural racism. The Color of Law by Richard Rothstein, shown here, serves as the text for the conversations and case studies in my course. And the quote here reads, "Today's residential segregation in the North, South, Midwest, and West in the United States is not the intended consequence of individual choices and of otherwise well-meaning law or regulation, but of unhidden public policy that explicitly segregated every metropolitan area in the United States." So how do we realize a future of sustainable communities for all? Equity is a key part of creating healthy, resilient, and sustainable communities. So let's talk about this. Low-income communities and communities of color are more likely to face higher urban temperatures and are more vulnerable in extreme heat events. Since UHIs disproportionately impact low-income and communities of color, they are an environmental justice and public health issue. Figure 6 here illustrates the correlation between income level and surface temperatures across the cities in the United States. Across 4 cities in the United States. So you can see here that the lack of green spaces and cool materials in low-income communities leads to higher surface temperatures caused by heat-absorbing urban materials such as asphalt. Figure 5 shows the lack of tree cover in low-income neighborhoods in Washington, D.C., compared with middle-income and high-income communities. Low-income communities and communities of color are also more susceptible to heat due to a lack of access to cool and safe indoor environments and civic amenities like cooling centers. Often, low-income residents cannot afford effective and efficient air conditioning systems, and thus they rely on community cooling centers. But these centers are also often few and far apart. Worsening this situation is a lack of access to safe and affordable healthcare in cases of heat-related illness, which causes more fatalities, especially during heat waves. Low income and marginalized communities are significantly more heat vulnerable because of discriminatory land use policies, lack of investment in historically marginalized communities, and associated crime safety concerns by residents and the community. Historically, redlined communities are much hotter than non-redlined neighborhoods because of a lack of investment in their maintenance and upkeep, such as tree canopy, effective cooling structures, and safe construction materials. You can take any map of any major city in the United States and overlay a red line map, and you can see a lot of these health and equity and environmental disparities. Figure 7 shows the difference in average temperatures in various neighborhoods, and as you can see, the neighborhoods with a rating of D are much hotter than the average city temperatures. Out of 108 urban areas studied, nearly all redlined areas in cities had higher temperatures than non-redlined areas, some by nearly 13 degrees Fahrenheit. There is actually a neighborhood that we were looking at Drexel that was 20 degrees Celsius higher than surrounding areas. Our next section talks about some LEED credits as they relate to urban heat island effect and heat equity. So all of you are probably really familiar with LEED. LEED stands for the Leadership in Energy and Environmental Design Rating System. It's USGBC's third-party verification system for green buildings at all scales. And LEED is the most widely used green building rating system in the world and an international symbol of excellence. LEED buildings are a critical part of addressing climate change, enhancing resilience, and supporting more equitable communities. So here are some credits that are relevant to heat island reduction, and we'll be going through some of these today, including the heat island reduction credit, the heat island mitigation through cool walls pilot credit, the carbon sequestration through plantings pilot credit, social equity pilot credits, the protect or restore habitat credit, and the open space credit in LEED. I think we froze. Oh, no, we're good. So the first credit in LEED that's leading the charge on combating extreme heat is the heat island reduction credit under the sustainable sites category. A lot of you are probably familiar with this credit. The goal of the credit is to minimize inequitable effects of microclimates and human, especially frontline communities and wildlife habitats by reducing heat islands. We recently updated the intent section of the credit to include the language inequitable effects and frontline communities in order to explicitly recognize that heat islands are an environmental justice issue and they must include equity in the solution. To earn the 2 points in the credit, projects can choose non-roof or roof measures and use any combination of non-roof and roof measures or parking under cover. Examples of non-roof and roof measures include installing plants to provide shade over paving areas, providing shade with energy generation structures such as solar thermal collectors, photovoltaics, or wind turbines, using paving materials with high solar reflectance value, or using an open grid pavement system and high reflectance roofs. Many projects have achieved this credit with an achievement rate of over 70%, and some will be highlighted later in this presentation. So as Ronan mentioned earlier, we recently released a pilot credit titled Heat Island Mitigation with Cool Walls. It's similar to the first credit, but is more specific about the process it uses to reduce heat islands and focuses on vertical walls. Cool walls are walls often painted a cooler color than usual to increase the SR value of a building by allowing it to reflect more of the sun's heat back into the atmosphere instead of absorbing it. And conventional walls reflect about 25% of the sun's heat, cool colored walls about 40%, and dull white about 60%, bright white at about 80%. I'm sure a lot of you already know all of this. Cool walls allow heat to be released from infrastructure that would otherwise hold on to it and thus reduce the urban heat island effect. This also reduces a building's cooling load, thus saving energy, and in turn, greenhouse gas emissions. So the requirements for the credit are that at least 75% of a building's gross exterior wall are a cool wall with specifications about what qualifies as a cool wall, where the cool wall must be located. Our most recent data shows that there are 5 projects registered for the pilot credit, which has only been open for about a year. Out of the 5 projects, 1 project is currently working towards meeting the Cool Walls pilot credit, and it's an industrial manufacturing project. This project is using the version 4 BDNC core and shell rating system to increase its SR values and reduce the urban heat island effect. So this is just a graphic that illustrates the difference between a regular roof and a cool roof. So the next pilot credit relevant to urban heat islands is assess and increase on-site carbon sequestration credit, which we're hoping to shorten the title to on-site carbon sequestration through plantings. This credit intends to increase awareness and understanding of a site's carbon, and it's also only been out for about a year. The first requirement in this credit is to use the most current version of the Forest Service iTree planting calculator. If you're not familiar with it, you use the calculator to assess the amount of carbon sequestered by trees and shrubs on the site. And once a baseline is established, the project can increase on-site carbon sequestration by at least 10% as compared to the baseline site, or use alternative strategies. For example, the Pathfinder tool by Climate Positive Design to get those numbers. An alternative strategy must submit a proposal that aligns with the intent and goals of the credit, explains how it sequesters carbon, identifies metrics that will be used, and demonstrates at least a 10% increase in carbon sequestered. So this credit reduces urban temperatures by increasing green spaces and vegetation on a site that evapotranspirates and regulates temperatures. In figure 9, we're showing the difference in temperatures between asphalt roads versus trees. Right now, the Sustainable Sites Technical Advisory Group, which I help facilitate, is discussing how to account for carbon sequestration through materials and perhaps creating a pilot credit around materials sequestration, so active sequestration. So stay tuned on that development. So lastly, these 3 pilot credits are social equity pilot credits, include social equity in the community, the project team, and the supply chain. And they're key in thinking about heat equity and reducing the urban heat island effect justly, as well as having less of an impact on workers in the supply chain and on the project team. So social equity in the community emphasizes community involvement and needs. Social equity in the project team encourages strategies to reduce disparities in the workers on the project. And social equity in the supply chain aims to create an equitable environment for anyone involved in any part of the LEED project by aligning with the 8 ILO conventions for fundamental rights of work, half of which surround child labor and forced labor. Considering these areas of equity while designing and developing plans for heat island reduction through green or cool roofs and walls is key to ensuring an equitable project and reducing the environmental injustices faced by heat vulnerable communities across the world. Social equity in the project team's achievement numbers, it's on the top 3 for pilot credits in our entire pilot credit library. So it's a very popular pilot credit. 54 projects achieved, so for project team, 135 projects were awarded points. For social equity in the community, 54 projects were awarded points. And in social equity in the supply chain, which was just recently published, there are 4 projects achieving that pilot credit as of December 2021. So let's look at the impacts of LEED. A study published in MDPI journals found that using GIS and spatial regression models, that constructing LEED certified buildings in a 30-meter area could lower the temperatures in the surrounding environment by 0.35 degrees Celsius. A LEED Gold or a LEED Platinum certified building could lower that temperature up to 0.48 degrees Celsius, while a silver or certified status could lower the temperature by 0.26 degrees Celsius. These small temperature reductions caused by one LEED building can be multiplied by certifying more existing and new buildings with the LEED rating system. The more LEED certified buildings there are in cities, the less the urban heat island effect will impact the growing urban population. So lastly, to cover some real world examples of using LEED to reduce the urban heat island effect, we'll talk about some case studies. So first I want to bring up our pilot rating, our beta rating system, the LEED Cities rating system. So our LEED for Cities and Communities rating system is a pilot certification program that supports progress towards better, more resilient cities. It's available through the ARC Performance platform, and LEED for Cities goes further than the building scale and provides cities with solutions for measuring and managing energy and water use, human experience, waste production, and transportation usage on a city scale. There's also a demographic assessment required in the city's rating system, so it looks at equity in the community in that regard. Case studies undertaken by the LEED for Cities team to tackle urban heat island were focused on projects and campaigns in Louisville, Miami Beach, and Cincinnati. So let's talk about Louisville, Kentucky. Louisville was one of the first large cities to undertake such a large-scale study. The city found that parts of Louisville had temperatures up to 10 degrees Fahrenheit hotter. Louisville has the fastest growing urban heat islands in the country. On average, Louisville was 4.8 degrees Fahrenheit hotter than rural areas from 2004 to 2014. Temperatures in Louisville have been increasing by 0.65 degrees Fahrenheit per decade since 1960. To improve quality of life and reduce the UHI effect, they invested in cool and reflective roofs. Through the Cool Roof Rebate Program, which offers $1 per square foot for installing Energy Star rated roof, they were able to achieve credits. And property owners installing reflective roofs save 7 to 15% on cooling costs. 70% of the program's funding goes to vulnerable neighborhoods that were historically redlined in 2017. The Cool Roof Rebate Program had incentivized the installation of over 820,000 square feet of cool roofs. The Green Heart Louisville program to test the effects of the heat and greening on health and well-being on residents was used. And Parkland Plaza, so they turned Parkland Plaza, an unused city-owned parking lot, into a green space with trees, parks, and cool pavements. And now we're going to look at Miami Beach, Florida. So in Miami Beach, rising urban heat and other impacts of climate change, such as rising sea levels, saltwater intrusion, and stormwater management led to the creation of an urban heat island ordinance to address the impact of climate change. They also have a green building ordinance that requires every new construction over 7,000 square feet to be LEED Gold or meet the Living Building Challenge. Urban Forestry Master Plan in Miami Beach aims to increase urban canopy coverage to 22% by 2040. In Cincinnati, Ohio, there's a disproportionate heat impact on vulnerable populations, and they found that using citizen science to collect 10,000 data points over the course of a day really helped improve their goals and targets. Targeted improvements to vulnerable neighborhoods and was helpful, and currently some neighborhoods have over 70% canopy coverage, while historically redlined neighborhoods have less than 10%. The goal is to improve overall canopy coverage to 40% and also installing indoor and outdoor cooling stations, especially in heat vulnerable neighborhoods. Adding cool pavements by rolling back requirements for parking lots in certain zones also helped Cincinnati meet their LEED cities requirements. So that's just a couple of case studies from a case study packet that is available online at usgbc.org that we did a couple of years ago. Another project we wanted to highlight is the National Museum of African American History in Washington, D.C. It's a LEED Gold certified building that has integrated heat reduction and equity throughout its design, construction, and management process. Some sustainable design features at the museum are passive design to reduce the environmental footprint of the project. Exterior corona with enclosing glass panels in a box within a box structure filters light to reduce heating and cooling costs. North-facing light monitors to diffuse natural light throughout the museum were also installed, as well as a solar panel covered roof and an underground dual cistern system that conserves water by reusing it and prevents flooding during extreme events. The porch of the museum creates a cooling microclimate by using the south breeze that flows through the water. It can be up to 10 degrees cooler. As for social equity, the project does not explicitly have the LEED pilot credits under their belt, but they have integrated equity throughout their project team and supply chain through design. The design was designed by a project team of Black architects. Management was through a Black-owned management firm. 1 in 3 contracts was Black-owned, and hiring Black and minority individuals in the operation and maintenance of the museum. They also provide free admission to the museum, which allows everyone to access it equitably. So what's next? Right now at LEED, we're discussing how to find solutions to the following. And I'd love to hear feedback from any of you on these issues. One of them being the inequitable disparities in extreme heat. As we talked about, there are a multitude of disparities, and when you see the extreme heat in these neighborhoods, and you also see the increased cost of cooling, it's just a bunch of impacts on these neighborhoods. Also, we have cleaning of roofs. So a lot of project teams have reported to us that to clean their roofs, they have to use a detergent, which is not a green solution, but also it will affect the albedo of the roof over time. So we're looking to try to find solutions to cleaning cool roofs and cool walls. The cost of maintaining a green roof or a cool roof, lack of education around all of the topics that I mentioned today, and then perception that designing for heat island reduction is expensive and does not have a good return on investment. So these are all issues that our committees are currently tackling today. So if any of this interests you and you want to get more involved in LEED technical development, the U.S. Green Building Council's call for volunteers, which is a call for sustainability professionals to serve on LEED committees, is now live. LEED committees are charged with developing the LEED rating system requirements and are comprised of volunteers committed to improving the design, construction, and operations of buildings. And you can see at this link provided at the bottom of this slide, you can see the application and apply. Given all of everyone's expertise in this room, I'm sure every one of you would be a great candidate to consider for the committees, and we're accepting applications for all 6 technical advisory groups and the LEED advisory committee as well. And you can find more information again about these opportunities at the link. I hope you'll consider submitting as the application period closes on August 20th. So thank you, and I really appreciate speaking to you today. Here's my contact information. Thank you.